So up until now, we've been solving inequalities that only take one operation to get x by itself or a variable by itself, and we can write the solution set. In this section, we're going to be solving inequalities that take a few steps. So let's go ahead and look at a few examples. We actually know how to do these because we've done them with equations, only we are doing with inequalities now, and there's actually really only one or two subtle differences that we need to take note of. So let's look at the first one. We have 3x minus 4 is greater than 1. Okay, and just like if this were an equation, we're just going to solve this by adding 4 to both sides. Adding 4 to both sides. Our overall goal, remember, is to get x to the left by itself on the left side and everything else on the right side. So we're moving everything else to the right. So we have 3x is greater than 5. Let's go ahead and divide both sides by 3. These two terms cancel, which just leaves us with x is greater than 5/3. All right, now in this section, we're going to give the solution in interval notation and also with a solution graph. So we're going to take the solution set here, and we're going to write it in interval notation and graph it on a number line. So our interval notation will look something like this. We're looking for the values that are greater than 5/3. So we're going to have an open parentheses at 5/3. We're not including 5/3 in our solution, and we're including all the numbers greater than 5/3. So all the way out to positive infinity. Remember to always use a parentheses when dealing with infinity because we can't include it because infinity is actually not a number, it's more of a concept. All right, so that's our interval notation for our solution set. Let's graph it on a number line to get our solution graph. Let's see what this looks like. So we have 5/3 in the middle. And let's go ahead and put 8/3 over here. This actually looks very similar to the solution graph we made in a previous video. So this is minus 1/3. Okay, so at 5/3, we're not including that in our solution, so we're going to have an open parentheses, and it's going to open to the right because we're going to shade to the right. We want all the values that are greater than 5/3, and that's our solution graph. All right, not a whole lot to it. We should be pretty good at doing this by now. Let's look at the next one. We have 5x is greater than 3x minus 12. Okay, here we have x on both sides of our equation, but that's nothing to write home about. We're just going to subtract 3x from both sides. Minus 3x minus 3x. These two terms cancel. 5 minus 3 is 2, so we have 2x on the left side is greater than minus 12. Let's go ahead and move this 2 to the other side by dividing both sides by 2, leaving us with just x on the left-hand side. X is greater than minus 6. So x is greater than minus 6 is our solution set for this inequality, and we want to write it in interval notation and we want to write the solution graph, draw the solution graph. So let's take a look. So we have minus 6, and we're looking for the numbers greater than that. So minus 6 is going to be on the left with an open parentheses because we're not including minus 6, but we're including all the numbers greater than minus 6 all the way out to positive infinity. So that's our interval notation, and our solution graph is going to look like this. This goes out into positive infinity, negative infinity. Minus 6 is in the middle. Let's go ahead and write out a few terms just so there's no ambiguity of which side is the positive side in the positive direction and which side goes in the negative direction. Okay, so we're looking for all the values that are greater than minus 6, not including minus 6. So we're going to have an open parentheses to the right, and we're shading to the right, which includes every number from minus 6 out to positive infinity. All right, let's look at another one. Let's say we have the inequality 7x is less than 2x minus 8. Okay, let's go ahead and we like to get our variables on the left-hand side. So whether we can move this to the right or this to the left, it's the same. I just like to have my variables on the left-hand side because I'm just more used to it like that. So let's subtract 2x from both sides, which gives us 5x on the left-hand side, less than a minus 8 on the right-hand side. Let's go ahead and isolate our variable, divide both sides by 5. These two terms cancel, which gives us x is less than minus 8 over 5. That's our solution set, and we want to write it in interval notation, and we want to draw the solution graph of it. Okay, so we're looking for all the numbers that are less than minus 8 over 5. So minus 8 over 5 is actually going to be the cutoff point, and we're not going to include it. So we're going to start out with minus negative infinity. So all the numbers from all the way from negative infinity all the way up to minus 8 over 5, but not including the minus 8 over 5. So we're going to include a parentheses here. So this makes sense. So we're including all the numbers starting with negative infinity all the way up to minus 8 over 5. And let's see what it looks like on a solution graph. These are very intuitive. We should be very good at this by now. So we have minus 8 over 5. Let's just write a couple more points in each direction. We have minus 13 over 5 and minus 18 over 5. Positive direction, we have minus 3 over 5, and we have a positive 2 over 5. This is going in the positive direction. This is going in the negative direction. Okay, so we're going to shade everything to the left of minus 8 over 5. Our parentheses is going to open to the left because we're not including this in our solution. And we're shading to the left. We're including all the values less than minus 8 over 5. All right, not a whole lot to these. Let's go ahead and squeeze in a couple more up here. Your selection, okay. Let's take a look at the following inequality. We have, we have 4 plus x. 4 plus x is greater than 6 minus x. So again, we have a variable on both sides. I'd like to move them to the left. I like to have my variables on the left, so let's go ahead and add x to both sides. This gives us, let's write the variable first. We have 2x. 1x plus 1x is 2x, plus 4 is greater than, these two terms cancel, greater than 6. Let's go ahead and move our 4 to the other side by subtracting 4 from both sides. So we have 2x is greater than 2. Let's isolate our variable by dividing both sides by 2. So we have x is greater than 2 over 2, or just x is greater than 1. So this is our solution set, and we want to give the solution set in interval notation and see what it looks like on a number line. So interval notation, we're looking for all the numbers that are greater than 1. So we're starting at 1, we're not including 1, so we're putting a parentheses here, and we're including all the numbers going out to positive infinity. And that's interval notation for our solution set. So let's see what it looks like on a number line. That's negative infinity. This goes out to positive infinity. We have 1 in the middle. Let's go ahead and give a few more values. Minus 1. Okay. So we're shading to the right of the point 1. So we're going to have an open parentheses at 1, excluding the point 1. And we're including all the values greater than 1. And that's all there is to it. So let's just do one more, just for a little bit more practice. Let's look at 2 plus 3x is greater than or equal to 5 times 5x minus 2. Okay, this one's going to take a few steps. So let's go ahead and get started. Let's rewrite the left-hand side and work on the right-hand side first. So we have 2 plus 3x is greater than or equal to. Let's go ahead and distribute this 5 into the parentheses. So we have 25x. 5 times a minus 2 is a minus 10. Let's go ahead and move our x to the left-hand side. So let's subtract 25x from both sides. So we have a minus 22x plus 2. I just switched the arrangement of these two numbers. Greater than or equal to, these two terms cancel, so we have minus 10 on the left-hand side. Let's go ahead and subtract 2 from both sides to cancel those two terms. So we have minus 22x is greater than or equal to minus 12. And we can isolate x by dividing by minus 22. These two terms cancel, so we have x. And again, we're flipping our inequality sign because we're dividing by a negative number. We never want to forget that. So our greater than or equal to sign becomes less than or equal to. So we have x is less than or equal to. These negative signs cancel, which gives us a positive 12 over 22. And we always want to simplify as much as we can. So we can actually simplify this, factor out a 2 out of the top and the bottom, giving us 6 over 11. So our solution set is x is less than or equal to 6 over 11. In interval notation, we want all the values that are less than or equal to 6 over 11. So we're going to start all the way out to the left in negative infinity, and we want all the values up to 6 over 11, and the equal sign says we're going to include 6 over 11 in our solution set, so we're going to put a bracket here. All right, now we're going to look at the solution graph. This goes to negative infinity, this to positive infinity. We're putting 6 over 11 in the middle. This will give us, let's go ahead and write out a few points, 17 over 11, 28 over 11. A few points over here, so we have minus 5 over 11, minus 5 over 11, and minus 16 over 11. Okay, so what we're looking for are all the values from all the way in negative infinity all the way up to 6 over 11. So we're going to include 6 over 11 in our solution set by putting a bracket, and it's going to open to the left. It's going to open to the left because we're shading to the left. So we're including all these values in our solution set, all the way to negative infinity. And there's our answer. We naturally have our answer in inequality notation because that's how we solve it. So we went ahead and wrote it in interval notation, and in we drew the solution graph. There's a fourth way to there's a fourth notation to write our solution set, and that's in set notation. But we're not going to use that a whole lot in this course because it's really reserved for a proofs course, which we may add in the future. So we're getting used to solving multi-step equations that take more than one step, which we should know how to do by now because we've done so many linear equations that take multiple steps. So most of everything works the same way except when you're dividing or multiplying by a negative sign, and we need to realize that the solution to an inequality is actually a set or an interval of numbers, where an equation is usually a specific value. So we'll do another video on this, and we'll look at a few more examples of solving multi-steps equations. Let's actually do it in the next video. I'll see you soon.